So 64, it's asking, this has a G prime graph. And the first thing it says is G prime of 0. So what is G prime of 0 from this G prime graph? It's -3. Okay. I heard a 0. G double prime of 0 would be 0. But we already have a slope graph going on here. All right. So what is G prime of 3? 0. Which means it's a horizontal tangent right there of G. That's what that means. All right, let's look at C. What can you conclude about the graph of G knowing that G prime of 1 is -8/3? What do you know? What's happening to this graph of G if my slope is negative? It's going which way? Down. All right, D. The graph of G from G prime of -4 is 7/3. What does that mean? G is going up at that time. All right. This is really where I want to talk about. Is G of 6 minus G of 4 positive or negative, and explain why? Well, what do we know about G prime from 4 to 6? It's positive. Okay, G prime is positive. Does that make sense? If G prime is positive, my function is going up. Agreed? And so if my function's going up, here's 4 and here's 6. What do we know if we take 6 and we subtract from G of 6 minus G of 4? That would be a positive or a negative? That'd be a positive. All right? Because G prime is positive there. All right? So that would definitely be a positive. Good, good? All right, let's get our... So this is 2.2b. 2.2b, rate of change. That's what we're going to call it. So if I have displacement a lot of the times in calculus is with an S. In physics, a lot of them use an X of t. We're going to use S of t a lot of the times here. But it's really just your change in your Y values, basically. All right. But if we talk about average velocity I want you to think of as algebra slope. I want you to think of it as algebra slope of your distance. So it's going to be your change in distance over your change in time. But I want you to write down average velocity is algebra slope of distance. So we all got that? We're moving. So I want you to write these two things down, or a few things actually. Velocity tells you two things. It tells you speed and it tells you direction. If my velocity is positive, I move forward or I move up. If my velocity is negative, I move down or left or backwards or something like that. All right? When you drive a car, you have a speedometer. All right? Speed is absolute value velocity. And let's talk about what that really means. When you drive a car, you go forward, it tells you your speed. True that? But if you go backwards, it also tells you your speed. But if it said velocity, guess what it should have on your little dash? Negative. It should say -15. Yeah, we crazy. All right. Anybody else back out of the driveway kind of fast sometimes? No? Just me. All right, cool. You guys are all safe drivers. Allstate. You're in good hands. All right. Good, good. So speed tells you what? Speed is your absolute value velocity. I'm sorry. Velocity tells you what? Speed and direction. All right, we good? All right, we're moving. So we're going to find average velocity, and I need a reader up, and her and Gigi's going to read for me.
If a billiard ball is dropped from a height of 100 feet, its height s at time t is given by the position function s equals -t squared plus 100, where s is measured in feet and t is measured in seconds. Find the average velocity over each of the following time intervals.
All right, so what are we trying to find? Average velocity. And average velocity is algebra slope with position. So here's my position equation. And now I have an interval 1 to 2. So we find average velocity by doing algebra slope with it. So all I'm going to do is do s of 2 minus s of 1 over 2 minus 1. Do you see how it's just the algebra slope of it? All right, so now we're going to substitute in 2. So 2 squared is 4. 4 times negative 16? Negative 64 plus 100? 36. All right, so now we have 36 minus, now we're going to substitute in 1. So now we have 1 squared, which is 1 times negative 16, which is plus 100 is 84. So I have 84 right there, and then it's all over 1. So 36 minus 84 is negative 48. 48. And my units would be feet per second. Why is it negative? Because it's going down. It's falling. All right? Does that make sense?
Yes.
All right. What is its speed? What is its average speed, I should say? 48. All right, cool. Part B. So now I have to do my interval from 1 to 1.5. So now I'm going to just do the average velocity, which is just algebra slope of position. So I'm going to do s of 1.5 minus s of 1 over 1.5 minus 1. All right, so now I substitute in 1.5. And what is s of 1.5? Anybody know what 1.5 squared is? You guys have calculators? 9 over 4, fine. All right, and then multiply it with negative 16. So the 16 and the 4 is canceled, and negative 36. So negative 36 plus 100 is 64. Minus, now I substitute in 1, and I already know it is 84. Over 1.5 minus 1, which is 0.5. So now I have 64 minus 84 divided by 0.5. So I end up with negative 40 feet per second. So the average speed, the average velocity, I should say, is negative 40 feet per second from time 1 to 1.5. All right, pretty good? All right, we're moving. All right, so I want to talk about the position function. And if you're in physics, you should be comfortable with this. If you're not, we also do it in calculus, and then physics steals it. That's cool too. All right, so we have 1/2. This is your normal position function. So s of t is your normal position. That's how it's notated normally. We will do x of t sometimes. That's how physics does it, I guess, at this school at least. So we have 1/2. My gravity constant, so that g is your gravity constant, and then t squared plus v of 0, and that's called your initial velocity, plus s of 0, and this is called your initial position. So the initial is where it starts out at. All right, so it starts out at a certain position. It starts out launching or falling at a certain velocity sometimes. And then we have our gravity constant out front. Now, I'm just going to go ahead and give you your gravity constant now. Our gravity constant, when we're in customary units, is negative 32 feet per second squared. All right, when we're in like our English feet unit things. All right, and if we're in metric units, we're just going to use negative 9.8 meters per second squared. All right. You can go a lot more decimals than that. When I was in AP Physics back in the day, we used negative 9.81 because that 1/10 of a or 100th of it. Anyway. All right. All right. So that's our position function. We'll be working with that a little bit. This is what I want you to write down. Instantaneous velocity is taking a derivative of your position. Your instantaneous velocity is your calculus slope. That's how I want you to think of it. Average velocity was what? Algebra slope. Instantaneous velocity is calculus slope, which means we're going to be taking that D word, derivatives. We're going to be taking derivatives. All right? So if I have a position function and I need instantaneous velocity, I'm going to take a derivative. And that's more of how your cars work. Your car is an instant speed. You following me? That is the moment in time that car is going that speed. It is doing a derivative in that program. All right, pretty cool. All right, so that was just those constants that I already gave to you. All right, we're moving. All right, I need a diver. Anybody swim? Anybody swim? Shark bait, go for it. I don't know your shark bait, so.
Equals 0. A diver jumps from a platform diving board that is 32 feet above the water. See figure 2.21. The position of the diver is given by S of t equals negative 16t squared plus 16t plus 32. And t is measured in feet and t is measured. S is measured in feet and t is measured in seconds. When does the diver hit the water?
All right, let's find that first. All right, so when does the diver hit the water? So here's my position function of my diver. First of all, I'm in customary units because I'm in feet. And then, what is my initial velocity? How fast is that diver springing off my little board? 16. Okay, 16 feet per second. That's how fast he's springing up, I guess, or she, or whatever. And then, what is this 32 thingy? The distance to the water that he starts on the little board, or she starts on the board. All right, does that make sense? All right, so that's how we kind of read it. But when does the diver hit the water? So when is the diver hitting the water?
When t is 0?
Not t is 0, that's time 0. At time 0, where's he at, or she?
The top.
At the top. Okay, it's at 32 at time 0. True that? When does the diver hit the water? What is at 0? S of t is equal to 0. So now I'm going to set 0 equal to my function. All right. Now on this one, we can do this one by hand without using a calculator. I have a quadratic. What do we like to try to do with quadratics? Factor them. This one plays really nice. So I'm going to factor out a negative 16. So now I'm left with t squared and then minus t and then minus 2. Love it. And then I can factor that some more. And what am I left with? T minus 2 and t plus 1. So I end up getting t equals what? 2 and t equals negative 1. Now, what doesn't make sense? Negative 1. We are not going back in time where this diver is meeting the water. Okay, we can't do that. All right, so at time equals 2, the diver is hitting the water. Good, good? All right, part B.
When is the diver's velocity at?
All right, fantastic. What kind of velocity are we talking about here? Is it average velocity? Or is it instantaneous velocity? It's instantaneous velocity. It doesn't say the word average anywhere. So we know it's instantaneous velocity. What does that mean we need to do? We need to do calculus slope. So we can notate it both ways, and I'm going to show you. We can say it's s prime of t. That is fine. Or we can just jump to v of t. All right? That is okay to use s prime or v of t when we're talking about taking derivatives of position. Does that make sense?
Yeah.
All right. So then I end up with, what's my derivative? Negative 32 t, and then plus 16. And then what happens to the 32? Goes away. All right. So now, what do I want to substitute in? A 2 for t. So now I want to find v of 2, or s prime of 2, if you notated it that way. So when I substitute in 2, I end up with negative 48 feet per second. Now, why is it negative? Because my diver is going downward. All right? I could ask this question too, and I will on your quiz next week. What is the speed at impact? 48 feet per second. But the velocity is what? Negative 48 feet per second. Does that make sense? All right, cool. I want you to write these down, and then I'm going to do a couple more with you. On 45, I think we're just taking a derivative. Yes?
Yeah.
All right, but before we take a derivative, I need to rewrite it. Just like when we had a quantity squared, what do we have to do here? We had to FOIL it, true? On this case, what do we have to do before we take a derivative term by term? Distribute dividing. We have to distribute dividing first. All right? So we're going to distribute dividing by x squared. I need to manipulate the way it looks so I can work with it easier. So x cubed over x squared is x. Minus 3x squared over x squared is 3. And then plus,
4 over x squared.
okay, it's 4 over x squared, but how am I going to rewrite it? X to the negative second. All right, I might as well just throw it to the top, get them in trouble. All right, so now I'm going to take a derivative. So how do I show that I'm taking a derivative? F prime of x. So what's the derivative of x? 1. What's the derivative of negative 3? 0. All right, so now what's my derivative of 4x to the negative second?
Minus 8x to negative 3.
Negative 8x to the negative third, but let's put them in let's simplify it right now. So it's negative 8 over x cubed. All right, because it goes to the basement. Good, good? All right. All right, now let's look at 63. Let's look at 63 now. All right, who's going to read 63 for me? Alina's going to read 63 for me.
The points, if any, at which the graph of the function has a horizontal.
All right, what does it mean to be a horizontal tangent? The slopes are 0. So I'm trying to get my slopes, and then I'm going to set it equal to 0. All right, you'll hear this a lot. When all else fails, take a derivative, set equals 0. All right, so let's take a derivative. How do I notate taking a derivative of this function? dy dx is equal to, the derivative of x is 1, the derivative of sine is cosine. So there's my derivative, and now I'm going to set that equal to 0. So now I have 1 plus cosine, and I'm setting that equal to 0. So let's solve for x. So what do? Subtract 1, so now I have cosine x is equal to negative 1. When does that happen? When is cosine negative 1? At pi. All right, and I don't need to use 3 pi because that's not on my interval 0 to 2 pi. Okay, so my only answer for a horizontal tangent is x equals pi.